This is the screencast for section 2.1, example 4. In example 3, you saw the long way of doing limits. Now we're going to make your life a lot easier. We've got a theorem 2, for polynomial and rational functions. The limit as x approaches c of f of x equals f of c. So all you have to do is plug in c to that function in order to find out what its limit is. Same with a rational function. If you plug in c for x in both the numerator and denominator, you'll be able to find out what the limit is. So let's look at example 4. The limit as x approaches 3 of x squared times 2 minus, well, you can read it. That means all I have to do is plug in 3 for every x. So now I don't need to write the limit anymore because I am taking the limit. I am plugging in 3 for x. And I get -9. Now part B, same thing. The limit as x approaches 2 of this rational function. I don't need to write limit anymore because I'm taking the limit by plugging in 2 for x. And I get that the limit as x approaches 2 of this function is 3. Which means if I graph this function and I look at the x values as they approach 2, the y values are going to approach 3. The now try problem number 9 asks me to find the limit of this polynomial as x approaches 1. So I don't need to write limit anymore because I'm just plugging in 1 to find that limit, and I get -15. This comes with 2 now try problems, so let's also try 11. This rational function, I'm going to take the limit by plugging in -3 for the y values because it's asking me for the limit as y approaches -3. The input variable here is y in this case. Well, in this case I got that the limit is 0, so as my y values approach -3 as my input, my output values on this function are going to approach 0.